In today's lesson, we're going to be learning how to do full real proofs, but before we do that, we need to see a couple postulates. The first one is called the substitution postulate. The substitution postulate states that a quantity may be substituted for its equal in any expression. What that means is that, let's say I have two expressions here, 5 plus x equals 7, and then x equals 2. So some number, some quantity, is allowed to be substituted for something that's equal to it in any expression. Well, I've got the x over here, and I can replace that with something that it's equal to. Well, down here I have that x is equal to 2. So that means I can just take the x that I have in my first expression and substitute a 2 in there, and I can make it then look like 5 plus 2. All I'm doing is I'm substituting in for x, I'm substituting the 2 that I know is equal to it. 5 plus 2 equals 7. It seems kind of crazy, but we're going to need to be able to point out exactly what we're doing. So even though it sounds obvious, we just need to be able to say, oh, the substitution postulate, that's when we're allowed to substitute. The addition postulate, if we take a look at that, that also is going to sound kind of weird, but it comes down to being something that's really kind of obvious. So if equal quantities are added to equal quantities, then the sums are equal. That sounds kind of obvious. If I have an equal amount added to other things that are already equal, then what I end up with, the sum, is going to be equal. Let's see what that looks like in an example. Let's say that I have 8 equals 5 plus 3. Are these equal amounts? Well, yeah, I've got 8, and if I do 5 plus 3, that's equal to 8. So these do check out. So I'll just say checks out. Well, if I add equal amounts to both sides, then the sums are going to be equal. So let's say I do 8 plus, I'll now maybe add 2. And then to the other side, I'll just do, well, it was 5 plus 3, and I'll add another 2 to it. I had an equal amount, the 8 and the 5 plus 3, those were equal amounts, and then I just added the same amount to each. I added 2 to each. That's the addition postulate. If I add the same thing to both sides, then they're equal. Well, the subtraction postulate is literally exactly the same. In fact, I can copy this and paste it down here, and then all I need to do is just say, oh, if equal quantities are subtracted to equal quantities, then instead of sum, I can say the differences are equal. An example of that would be, I don't know, let's say 6 plus 3 equals 9. And if I take away 1 from both sides, let me do 6 plus 3 minus 1 is equal to 9 minus 1. Well, they were equal at the top. 6 plus 3 is 9. 9 is equal to 9. If I take away 1 from both sides on the bottom here, they're still going to end up being equal. That's all the subtraction postulate is. Multiplication and division postulates work the same way. If I do 5 is equal to 5, and I do, oh, well, 5 times 2 is equal to 5 times 2. Obviously, that's equal. Same thing works out with division. If I have 10 is equal to 8 plus 2, these are equal amounts. If I then divide both sides by 2, 10 divided by 2, that's going to be equal to 8 plus 2 divided by 2. If I do the same thing to both sides, then they're always going to be equal. The only thing we need to learn, really all we learn now, is just, oh, that's called division postulate. That's called multiplication postulate when I multiply the same to both sides. It's called the subtraction postulate if I subtract the same thing from both sides. This becomes necessary, though, when we start worrying about full proofs. It sounds like there's a lot that's going on, but it's really not that crazy. So let's take a look at an example. First thing, I'm given, 3 times altogether 4x plus 7 equals 45. I'm given that, They want me to prove that x is equal to 2 if this is what I'm given. Now, the way I would go about doing this problem is before I start anything, I would just be like, okay, let me solve for this. And if x ends up being equal to 2, it works out. So I'll start solving for it. 3, 4x plus 7 equals 45. I'll start by distributing that 3 in there. I get 12x plus 21 equals 45. Okay, I need to get the x all by itself, so I'm going to take away the 21 from both sides, minus 21, minus 21. 45 minus 21 is 4, 2 left, it's going to be 24. The 21 and 21, they kill each other, and I'm left with 12x equals 24. Well, I need to get rid of that 12, so I'll divide both sides by 12. I get 12 divided by 12 is 1, so I get 1x, which is just x. 24 divided by 12 is 2. Well, we have just shown that x is equal to 2. But when we're talking about proofs, and this is a simplified version, when we're talking about proofs, we need to say why we're allowed to do each and every single step. A proof, again, let's review from last unit. A proof is a set of logical steps that bring me from one to the other. I need to make sure that none of those steps are a lie. So when we're doing real proofs, we're going to do what's called a 2-column proof to start out. In a 2-column proof, you're going to have, well, 2 columns. In the left side, in the first part, it's going to have your statements. And in the right part, it will have your reasons. And then what you do is you go about solving the problem as you would, except with each step that you take, you need to give the reason as to why you are allowed to take it. And that's where our postulates come into place. When I'm talking about my postulates, these are the reasons why I can do these different things. Let's take a look at an example as to how it's going to work out. So, first, you always start out with what you're given. So I'm going to write out just exactly what I was given. 3 times 4x plus 7 equals 45. The reason I wrote that down there is because it was given to me. All right, next. Well, what was the first thing that I did? I distributed that 3. So I'm going to then just distribute the 3 there. 3 times 4 is 12x. 3 times 4x is 12x. The next one is 3 times 7 plus 21 equals 45. The reason I was allowed to do that was by the distributive property. And I'm just going to write dist for the distribution property, the distributive property. I'll write the whole thing out for you for the first time. Distributive property. All right. Next, we just keep solving this problem. Well, after that, I took away 21 from both sides. And I was left with 12x equals 24. 45 minus 21 is 24. Yep. And we were allowed to do that because I took away 21 from both sides. That was my subtraction postulate, right? If I said my subtraction postulate, if I take away the same amount to both sides, then the differences are equal. If I take away 1 from both sides here, then it's still going to be equal. Well, that's exactly what we did in this case right over here. Is I took away 21 from here, I took away 21 from here. So the reason we were allowed to do that was by the subtraction. I'll just write SUB, subtraction postulate, P-O-S-T. All right, finally, I just got to try and get the x by itself. So I will divide both sides by 12. If I divide both sides by 12, 12 divided by 12 gets me 1x, which I can just write as x. 24 divided by 12 gets me 2. That was done by, well, I divided both sides by the same amount. That was done by the division postulate. I'll write in div postulate. If I divide the same thing from both sides, then it's equal. Well, I wanted to prove that x was equal to 2. I wanted to prove that x was equal to 2. Well, I have x equal to 2, x equal to 2. The final thing, if you want to be really, really crazy about this, I can then just say, or if you want to be really, really explicit about this, I can say, well, x is equal to 2. I want to prove that x is equal to 2, so I can just substitute in 2 is equal to 2. Well, I started out with a given, which I'm assuming is true. I took these steps that are totally true. The final step that I took right here was that 2 is equal to 2 because x is 2. That was the substitution postulate. Well, I just proved that x was equal to 2 given that. Just like we saw last unit, I had some given that I start out with. I followed a set of steps that are completely true, and I ended up with what I wanted at the end. Well, I ended up with a true statement. Let's take a look at one. Oh no, the final thing that we need to do for this is once I've got that I've proven that x is equal to 2, then you're just going to say QED. That just stands for some Latin phrase that basically says we're complete with this proof. We finished it. All right, let's take a look at one more example together, and then you'll get a chance to do some practice questions. In this next one, they want us to prove that x is equal to 7, given that 2x plus 7 equals 5x minus 14. Okay, well, let's get started. Brainstorming, I feel like I'm going to need a bunch of my postulates. I can either write those down there, or I can just solve it here before I start putting in my statements and my reasons. I'm just going to go right away on here. So, I've got that 2x plus 7 equals 5x minus 14. And the reason I can say that is because it was given to us. I'm just rewriting the given. That was given. Next, I'll just start solving this equation. Well, I'll take away 2x from both sides. You don't need to do it in this order. You can do it in a different order. And the reason I'm going to do that is the subtraction postulate. Subtract postulate is why I'm allowed to do that. I'll put a little dot to show that we're not writing that entire word down. And that's going to leave me off with 7 plus 5 minus 3. 5 minus 2 is 3x minus 14. Well, now I need to start getting the x by itself, so I'll do plus 14 plus 14. I can do this by the addition postulate. Okay. I'm left with 7 plus 14 is 21 is equal to 3x. Well, then I need to divide both sides by 3. I'm left with 7 is equal to x. That was by the division postulate because I divided both sides by the same amount. So that was our division postulate. And I was left with x is equal to 7. If I substitute in that 7 is equal to x, I'll get what I was trying to prove, that x is equal to 7. So I can write QED. I am done with this.